Hello, I'm David Williams. I have 16 years experience in software test automation. This video will be about how to write a REST API automation framework using bare Python. The application under test will be JIRA, and it will consist of 4 lessons. The first lesson is how to write a wrapper for your REST API. The second is how to write a layer to implement the wrapper. The third is how to make a test layer. And the fourth is how to add tests once you have your framework in place. I hope you enjoy the video and thank you for watching. Hello, this is a presentation on how to write an API testing framework from scratch. We'll be using JIRA as the application under test, and this will be written in bare Python. The framework layers will be as such: an API wrapper, a use case class with transaction functions, and then tests. Lesson 1 will be to create the initial API wrapper and get a working active session. Lesson 2 will be add transaction functions that call the previously written API wrapper. Lesson 3 will be create a test layer that calls the implementation functions. And lesson 4 will be to add function stubs that raise not implemented exception, close those stubs or code those stubs starting with the implementation layer, and add functions to the API wrapper if needed. Once the function stubs are developed into working functions in the implementation layer, they can be called from the test layer. So now on to the code. Okay, the first thing you do is to take your application under test endpoint and credentials and your headers and just put them in a YAML file. So here, in this case, my JIRA Cloud URL is API automation examples.atlassian.net. The user ID is API automation examples, and then your token goes here in your headers. Don't worry about remembering these because I'll make these available to you on GitHub and post a link in the video. Okay, so the modules I'm going to use here are the YAML requests, and then request.auth import HTTP basics, or HTTP basic auth. I make a class with a constructor in it. I'm just calling it JIRA API, and it calls the JIRA info that I previously showed you, and it will get you your URL token. And then I do request.session. In this case, the basic auth is enough to get into it and to get a session going. So I just set the auth to HTTP basic auth, and then just to make, and then also add the needed functions to get projects, get an issue, and create or update an issue, depending on whether you pass it a user ID or not. As you can see, it does a post if you need to create a new issue, and it does a put to update an existing. And I just have this simple code here. I create an instance, then I get projects, then I do get issue, and then I create a new issue, and then I can put a breakpoint here if need be. Okay, so now what I can do is I can put a breakpoint here and then do debug. And as you see, I'm getting 200 class responses on everything. Just to see what one of these looks like, we will do issue result 2. And as you can see here, you get all your content and your return. So this obviously works. So this concludes the lesson 1 for building the outer API wrapper. So now we'll go on to lesson 2, which is the implementation. Okay, so these are the changes now we're going to do for lesson 2. And I'll read through these and then illustrate them. Make a package for the API wrapper layer. So add code to init, the constructor init.py, will actually be the initialization for the module or the package. So you add you add code to locate the JIRA info file. Then we pass JSON instead of getting them a file. Remove the testing code at the end of JIRA _ API and rename functions to handle other entities besides issues. Then we'll make the package for the implementation layer. Again, we'll add code dunder init for the package so we can locate any files we need. Then we'll put the issue input YAML so that it will into this package, so it'll know what to load for JSON. We'll be passing to the API layer. Make a class to organize transactions by entity, project, issue, sprint, etc. The constructor of each inner class will contain the URL that points to each entity. And then notice that the parent class needs to be passed to the inner class to bind them together. So now I'll bring up the code. And I'll start with the JIRA API code. And as you'll see, I'm no longer passing files to get entity and to create update entity. And they're no longer say issue, they say entity. And we're still having some of the basic information like the JIRA URL, the token, the user ID, and the headers. That's still being passed at the API level. Okay, now I'll show you what I've done here at the dunder init for the package. I just use from package resources, import resource file name, and then I point to the file that's in the root of the package. And I do the same thing for the API implementation. Well, I will do when we go to the next step. For now, we're just doing this here. Okay, as you can see here now, and again, I'm just going to also show the imports I've done. I've done from JIRA API wrapper.JIRA API import the class JIRA API. So that way, that gives the ability to have access to the API wrapper. Now I've created an outer class called JIRA implementation. And you'll notice we have issue JSON being loaded from the YAML file. And then here's where I put access to the API wrapper, and then I create a reference to a project, issue, and a sprint. So I have a class project, and I'm telling it in the constructor that you have to pass it the implementation, which this is what binds the outer class, the inner class. And here's the project URL, and here we have implementation if we need it. So if we need to get a project, that's all we're doing right now with project. And then under issue, again, in the constructor, I'm passing it the implementation, the specific part of the URL to get to the issue part of the URL, and then here is where we get access to the implementation, which also includes access to the API wrapper. So get issue, I'm just calling API get entity, and then set story points. The name of the field is custom field _ 1.AUT26, and we pass the point value. So what we do is we take the issue JSON, we update the dictionary to have a different point value, and then we call from the API wrapper create update entity. The same thing for update summary. We pass it the revised summary, and then the name of the field is field summary, and again we just call the API wrapper create update entity. The same for description. We pass description, and then revise description, and then call from the API wrapper create update entity. And again, the labels, you can update the labels as well. And by the way, it expects a list for labels. That's why I call this label list. And that put a little stub here for Sprint because we're going to be doing stuff for Sprint later. Okay, so I'm going to show you now. This is in the UI, and the issue 86 currently has label 1C, label 2C, label 3C. So what I'm going to do now is change this to label 1D, label 2D, and label 3D. And I'm just going to debug this so that we can look at this. Right mouse click, debug implementation, and we all get 200 responses. Okay, and as we can see now, we got label 1D, label 2D, label 3D. And just one more time I'm going to do this. Okay, so here we are. Right now the labels are set for 86 to label 1D, label 2D, label 3D. And I'm going to debug again. And you see they just changed to E. Okay, and you can also see we got 200 responses here. So everything's good. This tests out, it's working, and now we have separate API wrapper and implementation layers. Okay, now into lesson 3. And in lesson 3 for this presentation, here's the changes, a summary of the changes that we'll go through. I added the ability to send JQL, which is JIRA Query Language queries, to implementation.py. I removed testing code from the file, add the ability to send either default JSON or custom JSON, and then I created a new Python file, and this is for the third layer, which is the test layer. So we've got 3 layers here. We've got the test layer, implementation layer, and the API wrapper. So this will be the top layer. And I created an issue test class that has passed the implementation layer in the constructor. I added code to create an issue and update story point completion with validation. Added code to compare input to results for updating story points to different values, and wrote the inputs and outputs to a YAML file. Okay, so one thing I did is I put the this code in the dunder init of the package, and then this goes on to the implementation file that I mentioned. And here's the query function that I put in here that we can now use to run JIRA Query Language. Remove the testing code from the bottom of the file, and through each of these issues, it'll either use a default or you can send it, you can override it. And now the final layer, issue tests. So I got one where we test create issues. And the first thing we do is we use that JQL functionality to get project AD, which is what I named the project for this example. Max results equals 1,000. And I'm getting the beginning issue count. Then I'm creating a new issue, extracting the new issue key. Then after the update's done, I'm also getting issues, and then I want to make sure that the ending issue count is greater than the original issue count. So this proves that an issue was indeed added. And if a new issue is not added, it returns none. And if it does, it returns the new issue key. And also, I added some handling code at the testing level for doing a update story points test. I get the starting story points, and if there's no change, if it's the same number of story points, you're not updating anything, so I'm just returning that value. Otherwise, I'm getting the update JSON so that you can look at it and do further analysis. Okay, and this is what my test of this code looks like. So first I'm going to create an instance of issue test. Then I'm going to create an issue, and it's going to return the issue key. So it tells me which new issue is created. Then I'm going to put in some sample story point values. 5, 1, 0, the letter A, -1, a lot of digits in pi, 10,000, 10, and 30. And then I'm going to have the results and the matches. And then the idea is I'm going to cycle through each one of these items in this list. And the output will give you the new key number, and it will give you the past story points, and what shows up in the system is the update. So I'm going to go ahead and run this now. And it takes a little while because each one of these represents doing several calls to doing API calls. Oh, okay, so it's finished. So now let's look and see what we got. Here's our story point matches. It created issue AD56. It sent a 5. It updated to 5.0 and so on. If you'll notice, the letter A did not do an update because it's an invalid value. And then I tried to enter this long version of pi, and it rounded it. Third significant digit. I set it 10,000, 10, and 30, and those all updated in the values. And I can also confirm this in the UI. Okay, here we are at the UI, all issues. And we've got AD56, and you'll see it's set to 30 story points, which in the code is the last value is updated to. So we see that this is working. Hello, this is lesson 4, where I'm going to demonstrate how to add new test cases to the API test automation framework that's been set up in the first 3 lessons. First thing I'm going to do is I'm going to rename the test file to test cases, because we're not just dealing with issue tests anymore. And here's a list of things that we'll go through. Renaming the file, put code for the issue test case to be its own function, write a function stub for the sprint test case that uses text and uses comments as the test steps, and then add not implemented exceptions to it until it's done. And also there's going to be function call stubs in implementation.py. I'll be adding function stubs for create sprint, set name, set start date, set end date, set goal, set state. And of course, I'll use the not implemented exception to prevent confusion with unfinished code, and also add a function that returns results from a JQL query string. And then in the JIRA API wrapper, I added a partial sprint update because it uses a post instead of a put, like many other update transactions. And also, because it's been called from the implementation layer, I added in the API wrapper a JQL query string. And then, as you can see, step 4 here, once all the functions that are needed in the API wrapper, I started adding calls to those functions at the implementation layer and removed any not implemented exceptions after each one is completed. Then I added the calls in the test cases Python file to confirm everything works, and removed all not implemented exceptions to show that we have a working framework. Okay, so here's an example of what I did. This is before I renamed it, so this was still called issue test, but I just put these comments you see here: add a sprint, change sprint end date, start date, close a sprint, and just put in comments that represented what I thought would be good steps in a test case. And then also I put a not implemented error in these things because I didn't want anyone to confuse these with completed code. Okay, and the end product looks like this. As you can see here, the issue test case, I have it enclosed in a function, and then I created a different one called sprint test case where I create an instance of the sprint test, and then I did create sprint where I capture the sprint ID, and then I update the name and confirm that I get a HTTP 200 code back. Then I change the start date, and then I would try to put the end date before the start date and confirm that it sends an HTTP 400 code or greater. Then I fixed the problem and made the end date after the start date. Then I set the sprint as active. Then I closed it. And then I attempted to reopen a closed sprint, which you cannot do in the API. And all I have here is in the issue test, which I should probably rename. No, actually, this is okay. Issue test is a class, and then I have another class here called sprint test. And I have then the create sprint, which calls the implementation. Then I do the update sprint, where if the name's the same, to save traffic to the server. If there's no change, then I just return the sprint ID. Otherwise, then I go to the implementation and set the name. The same with start. If there's no change in the data, just return the sprint ID. And then and you can maybe treat this as a homework assignment, but you can go to update sprint end, update sprint goal, and modify that code so that if there's no change, it just returns the sprint ID and saves traffic or saves on the volume of requests. Okay, now I'll show you what I'm calling here in the implementation layer. I have a outer class called JIRA implementation, and then I have nested classes called project, issue, and sprint. And you'll notice that in the constructor of JIRA implementation, self-project equals self-project, and you have to pass the a copy of the implementation. Same with issue and the same with sprint. And as you can see down here in the code, in the constructor of the inner class, you can see that we specify the URL for the sprint, and then we pass the implementation here. And then we're able to go into the API wrapper where we do create update entity for create a sprint, set name. We also are able to, then we call partial sprint update, because if you update the sprint, we'll go over here to the API wrapper, and you will see that when you do a partial sprint update, you're doing a post, where normally updating an entity was a put. So I had to create this extra function to deal with that difference. Okay, now what I'm going to do now is just run this in debug mode, just to show that this works as we would hope it would. So right mouse click, debug test cases, and then down here on line 121 it says sprint test case, and as you can see, I'm getting 200 responses except for where I'm trying to reopen the result. Then I'm getting a 400 response. And also on the first end date result, well, it doesn't show up because I use the same variable over again. But as you can see here, when you're trying to reopen a closed sprint, it gives a 400 error and everything else gives a 200. So as we can see, this works now. And of course, I will post all this code out on GitHub and put links in the description so that y'all can follow along. And thank you for watching my video.